This is Mr. Erlin. We are going to be graphing sine and cosine today. And I think it's important to think about it in a special way. So first of all, it could be y equals sine of theta. It could be y equals sine of x. Theta is just another variable. It's often used for angular measures, but oftentimes in pre-calculus and trigonometry, we will use x continually, especially if it's radians. 1, 2, 3, 4, 1, 2, 3, 4. I'm going to put an end right here. And what I did is I went a multiple of 4 over. I want to ensure that when I scale my axes, that I've got the ability to break it down into sets of 4. So I'm going to call this 360 degrees, which is the same thing as 2 pi. So in other words, I'm doing radians on top and degrees on the bottom. That means halfway here, I'm going to be half of 360, which is 180, and I'll be half the radian measure 2 pi with pi. And then if I go halfway again, this is 90, and this would be pi over 2. And if I want to find the halfway point here, there's a bunch of ways I could do it. I could say it appears that every 2 spaces is 90. So 90 plus 90 is 180. 180 plus 90 is 270. You could also do that averaging idea. In other words, if I want to find the midpoint between pi and 2 pi, I'll add them together. That's 3 pi, and then divide by 2. So this is 3 pi over 2. Now, when I graph the sine curve, I recognize that it has a continuous shape that goes on forever. But it also has this period where it covers exactly one cycle. And if we think about it this way, where it starts at 0, 0, and it ends its cycle after 360 or 2 pi, halfway in between, it's got to be in the middle. Oops, missed that. It's got to be here at 180. And then if that's in the middle there, right in the middle here is the high point. So if I were to scale this as 1, for example, and -1, at 90 degrees, I've got a 0 at 0, 0 at 180, 0 at 360. At 90, I'd be up at a high point, and then at 270, I'd be at the low point. So as you can see, 1/4, 1/4, 1/4, 1/4 gives me a nice shape to graph the sine curve. So in the event that we have changes to the amplitude or the period, we're going to do the same idea, but taking these transformations into place. So this is a 2 in front. When it's in front, that's the amplitude. And the period is still what it normally is. It normally takes 360 or 2 pi. In this case, it's scaled by radians. And the only difference here is that instead of my going up 1 and down 1, I'm going to go up 2 and down 2. Sine starts on 0, 0, finishes at 2 pi. Halfway through, it's at a midpoint again. The first quarter is a maximum value, but this time I'm going up 2. And the third quarter is a minimum. Instead of -1, I'm going to go down to -2. And there's my curve. The use of a transformation number here, right in next to the x, affects the period. The period is normally 2 pi. In other words, in the 2 pi window, it's able to do one cycle. But this number is what's called the frequency. In other words, it tells you how many times the curve happens in the normal period of 2 pi. So another way to think of it is you can take the period of 2 pi and divide it by this number to find out the period of one cycle. Again, this lead coefficient of 4 is our amplitude, so I'll put it here. Sine naturally begins at 0, 0. It finishes its first cycle at 2 pi. Oh, not this time, because our period is only pi. So it finishes at pi. Halfway between those two, at pi over 2, it's going to be at a midpoint, again crossing over the x-axis. Halfway between those, between 0 and pi over 2, is pi over 4. It's going to be up at a maximum, which in this case is 4. It's 4 times the one it normally hits. And then halfway between here, so 1/4, 2/4, this is going to be 3 pi over 4. It's going to be at a min, 1, 2, 3, 4, a local minimum. And there's my curve for one period. If I wanted to do a second period, I could. Between the pi and 2 pi, it's going to be at a 0. Here in between those, it's going to be at a high. Here in between those, it's a low. And now by putting a second one in here, I see that within the normal period, I get 2 of these. That's why it's a frequency. Or you can change the period by dividing by that value and finding out how long it takes to do one. Let's see if there's any other good ones we want to do here. Let's try this one, sine of 2/3 x. So the amplitude, because there's nothing in front, is still 1. The period, normally it's 2 pi, and I divide it by this value, 2/3. Dividing by a fraction is tough sometimes, but I can just copy, change, and flip. In other words, I copy the top piece. Instead of divide, I change it to multiply, and I flip this fraction. And now those cancel. I'm left with 3 pi. That's not going to be so good because I can't even fit that on here. But let's do this. You know how sine starts here at 0 and it should finish at 2 pi? We can still do that. Let's start it at 0. And if it were to go all the way to 3 pi, let's pretend it's out here somewhere. We'd put a dot there, and then we'd come halfway in. So example here is 1.5 pi, right? Halfway between pi and 2 pi. So that would be the half point of this full cycle. And then if this is 3 pi over 2, the midpoint again would be half of that. 3 pi over 2 divided by 2 is 3 pi over 4. And that would be our maximum, which is a 1. And then halfway between here, let's see, 1, 2, 3 is up. 1, 2, 3 is back to 0. So 1, 2, 3 would be down. And 1, 2, 3 would be up. Somewhere over here is the up. I can still show this as a viable curve. It's just not finished. Every time I go 3, 1, 2, 3, it reaches the next critical value. So that'd be a low. 1, 2, 3, that'd be a mid. 1, 2, 3, that'd be a high again. So now I've been able to show a couple of cycles on here. Well, it's not even a couple. It's one and almost another one. This one's interesting. Our amplitude is -3. We'll talk about that in a second. Our period is going to be 2 pi divided by 4/3, which is 2 pi times 3/4, which is 3 pi over 2. So this point here that we had before is now my finish. I start at 0, 0, finish at 3 pi over 2, halfway in between, 3 pi over 4, is my midpoint. Now, between these two, if this is 3 pi over 4 and this is 0, halfway would be 3 pi over 8. And normally I'd go up 1, but then I multiply that by -3. So in this case, I'm going to go down 3. And here I would normally go down 1, but if I multiply -1 times -3, I get +3. So I'm going to go up here to +3. And I see my curve. And I see that what I've done is I've done 1/3, one cycle. And then if I go another, what is it? 1.5, 1.5, that's going to be another low. And it starts its way back up. In other words, it's 1 1/3 of a cycle. 4/3. How does this change for cosine? It's largely the same. The difference is that because sine, I know it's backwards, but it looks like an S. Cosine kind of looks like that. It's kind of a U, but if you can visualize it as a C, that might help. In other words, it starts at a value of 1, or the maximum, instead of a 0. But we still do the same thing. 1, 2, 3, 4, 1, 2, 3, 4. Let's call this 360 or 2 pi, and we'll be back at a maximum again, because that's where it cycles over again. The difference, of course, is halfway between the two maxima, we have a minimum. So here, if this is 360, I'm going to go 1, 2, 3, 4. This is 180 or pi. And I'm going to go down 1 there. And if this is a maximum and this is a minimum, I expect in between it's going to go through 0. Maximum, minimum, in between it goes through 0. And there's my curve for cosine as a standard cosine curve. This is still the pi over 2, a critical value. This is 3 pi over 2, a critical value. How does that change then when we look at transformations here? Amplitude, ooh, a -2. Remember those? Period is not affected. It's a 1. So it's 2 pi over 1. So I'm going to start at my max. Oh, my maximum should be 1. But since I've got a -2 being multiplied, I'm going to start at -2. And when I finish a full period, I'm going to be at that same point. Halfway in between, it's supposed to hit a -1 times -2 is +2. These would be zeros. And there's my curve. Let's try cosine of 2 pi. Amplitude is still 1. Period is going to be 2 pi over 2, which is just pi. So I start my cosine curve at 1. I finish my cosine curve at the end of one period, also at 1. Halfway between is my negative, my low point, and these halfway points again are my midlines. And I could keep doing this. I see that every 1 is a critical value. So again, I could cover 2 full cycles in one period of 2 pi. How about this one? 5 times cosine of 1/2 x. Okay, so the 5 is the amplitude, and the period is going to be 2 pi over 1/2, which is 2 pi times 2 over 1. So that's 4 pi. Interesting. So I'm going to start at 0, 0. And instead of going up 1, I'm going to go up 5 times that. So I'm going to be way up here. And then I have to go to the end of the cycle. Well, if this is 2, that means I'm going to be way over here. That's 4. Okay. So I'm putting a mark way out here somewhere that doesn't really fit on my graph. Halfway between at 2 pi, I expect to be at a low point, which would be -5. Halfway between those would be my midline. And I've only got enough room here to show half of a cycle. Oh, but it goes the same the other way. 1, 2, 3, 4 to pi is a midline. So 1, 2, 3, 4 will be another midline. And then 1, 2, 3, 4 will be a bottom, a minimum point. And that gives me the whole curve. Hope this helps a little bit in graphing sines and cosines with amplitude and period transformations only.